So let's talk about troubleshooting of HPLC. And to do that, we'll use some specific questions that have come in recently into our lab. So I categorize a lot of these as, is my LC okay? Is my HPLC working? And let me show you some of the built-in diagnostic tools that'll help us come to the answer to that question. So first thing, the software I'm using is Agilent ChemStation. It's version B.0403. It's a little older software. It's probably 10 years old. It's one of my favorites. It's also, I think, one of the more popular ones out there in the world today. And let me start with the first question came in, and that is, what happens if my pump runs dry? What happens if my pump pumps air through my system? And the answer is, let's try not to make that happen. Let's try not to let that happen. And the way we do that is we could set a minimum pressure limit on the pump. So in the software, I'm going to go over to the pump, and under setup, notice here I have a maximum, which we understand what that means. This is the maximum limit of the pump itself. If you had a very special column or very fragile column, you would set the pressure limit of the column here. Minimum is typically set to 0, but I recommend you set it something above that, maybe 10 or 20 bar. You want to set it at a pressure that you should never, ever attain. So in other words, right now, my system is running at 256 bar. I know that there's no way it's ever going to get down to 20 bar unless it runs out of solvent or springs a leak. So by setting that as the lower limit, now if I were to run out of mobile phase, water or methanol, if one of them were to go dry, as soon as that air bubble gets to the pump, the pressure is going to drop and it's going to say, something's not right here, I'm shutting down. So that's what the lower pressure limit does for you. So now while we're in here, let me show you some diagnostic tools that'll help you really answer that question, is my HPLC working properly? So in this version of the software, under View, down what I call the 5th level of software, down here is something called Diagnosis. When this came out, I thought this was earth-shattering. I thought this really changed the face of HPLC because it put some expertise in the box. So now this computer can actually evaluate the HPLC and run tests and then evaluate the tests. So let me show you an example. So right now I have the instrument I'm running. It's currently running. I have a binary pump. I got the liquid auto sampler, the thermostat, and a diode array detector. And if I did something like clicked on the pump and just said update variables display, it's going to show me the day the pump was made. This was made on October 14th, 2005. It'll tell me the serial number, the number of hours it's been on, and that sort of thing. But then if I say, show me the module details, this is all the different components inside the pump itself. And if I point to one of them, that's the pressure gauge. I say, hey, tell me what that thing is doing. And it says, oh, it is reading the actual pressure right now, which is 255 bar. And notice what it opens up in this window. This is something called the pressure ripple. Pressure ripple is one of our greatest diagnostic tools for the pump because what it's measuring is short-term pressure changes. The rule is pressure ripple should be less than 2%. As you can tell, my pressure ripple right now is 0.14. That means my pump is in excellent shape. I don't need to see the maintenance records to know that. I am looking at the performance records, the performance criteria right now, and it's putting out a pressure ripple of less than 0.2%, which is 10 times better than the spec. So pressure ripple would be a really large number if I had an air bubble in the pump. So air bubble, the number one cause of problems in HPLC, air bubble gets trapped in the pump. It would show up here on the pressure ripple. So we also have some other fun things we can do once we're in here. Let me show you the diode array, because with each component, I'm going to have a series of things that are inside, and I could click to the lamp and it'll tell me how many hours the lamp has been turned on. This one's been on 1,300 hours. That's lamps are only spec'd for about 1,000 hours. So I'm on borrowed life here. So it would be great for me to ask the question, how good is my lamp? I mean, I'm about to run a bunch of samples. I don't want my lamp burning out in the middle of the run. So let me show you some cool diagnostic tests. So under the diode array, if we say show module tests, here I have a bunch of different tests that I could run out of them. I'm going to show you one of my favorite ones. It's called the DAD intensity test. And when I do this test, what it's going to measure is how many photons are actually reaching the detector. So I have a trick. I like to run this twice, with the flow cell in, with the flow cell out. Let me show you how this works. I've highlighted the test. It tells me what it is. If I say start, it's going to start the test, lamp, and the only way of knowing that is down here at the bottom. Oops, down here at the bottom left of the screen, it says processing. So what it's doing is it's measuring the lamp intensity, the amount of light that makes it to the detector at a bunch of different wavelengths. So first it says from 190 to 220. That's what we call the low UV. It says, I know a good lamp has more than 2,000 counts. My lamp right now has 90 counts. Uh-oh, that doesn't sound good, but don't freak out yet. Also, it evaluates it for us. It says, you have failed. You have an issue with that. Then if we look in the range that we usually care about, 220 to 350, I'm supposed to have at least 5,000. I've got 11,000 counts. So what does this tell me? This says that if I'm doing work up here at 221 to 350, I have a decent lamp. If I want to do work in the low UV, I'm not sure about it. Now, there's two things that affect this. We keep talking about this as the lamp intensity, but it's also a function of the flow cell and the cleanliness of the flow cell. So either the lamp is going bad or my flow cell is dirty. Here's a quick way to find out. We're going to remove the flow cell and then we're going to run this test again. So let me pull the flow cell out, and if you look at the diode array detector, the flow cell is right in here, and here we have a really bright light on the left, flow cell in the middle, the diode array detector on the right. So if I flip open this little door, I could pull the flow cell out. Now the flow cell, there's liquid going through it right now. What I find interesting is it's a really simple design. It's a block of stainless steel with a quartz window on each side, and then we just shine light in to see if the sample absorbs light. So I'm going to put a flashlight behind this just so you could see right through that. So that's a quartz window. Again, we use quartz because it's UV transparent. And the way this detector works is it shines light in one side, and since there's a sample in the middle, it's going to measure to see if that sample is absorbing that light. So it measures the amount of light. So now, with the detector out, we're going to run this test again. And sort of remember that we got 90 counts on the low UV, and that is less than wonderful. So now we're going to do the test again. And remember, we're counting the number of photons that are actually hitting the detector at various wavelengths. So now take a look at my low UV. 190 to 220, I'm supposed to have at least 2,000, and I actually have 9,520 counts. Wow. So tell me something about my flow cell. Is my flow cell clean or dirty? Yeah, the flow cell's a little dirty. How about my lamp? Is my lamp good or bad? The lamp is good. How do I know that? Well, because it passes all these tests, it means I have a good lamp, but my flow cell's a little dirty. Now, let me give you a reality check here. My flow cell right now has methanol in it, and methanol absorbs the low UV. So that's the real reason why I was failing the low UV. To really run this test properly, you're supposed to put acetylnitrile in the flow cell. But I think it's a great example to show you how right away I could validate my lamp is great. I know I've got plenty of intensity come out of the lamp. My flow cell is pretty great. My HPLC mobile phase right now is absorbing some of the light, but besides for that, I just sort of validated how good is my lamp and essentially how good is my detector. So I think that's a great example of the diagnostic part of the software. I think one of the cool things that you can do is you can say, I notice a problem in the baseline. Let's say I notice that my pressure is unstable. I wonder what would cause that. Well, as soon as I chose pressure unstable as my symptom, the instrument itself came up with a list of possibilities and said, you probably have an air bubble in the system. I think that's a great answer, because if you were to ask me, hey Lee, what's the cause of my unstable pressure? I'd be like, oh, I will bet 9 times out of 10, it's an air bubble in your pump. So it says it's probably an air bubble, and then it gives you the pressure ripple. It says, hey, if you think you have a pressure stability issue, you should probably be looking at this gauge right here. And this gauge, to me, says I have no problem at all, because it's less than 2%, way less than 2%. So that's how this works. If you go in here and you say you have poor area precision. So if you told me your area precision is bad, right away I'm going to say, ooh, let's take a look at your auto sampler. More specifically, let's talk about your rotor seal. That is the one thing that goes bad in the auto sampler, and when it goes bad, what does it cause? Area precision problems. So right away it came to rotor seal defective as a suggestion. So I think this is a great little tool. It will also sometimes suggest a test or a remedy. It will step you through how to do that. So if I had a pressure problem or a leak problem, it would probably suggest running a leak test, and then it would step me through how to actually run that leak test. So I've showed you a bunch of cool things in the software itself. Unfortunately, ready for some bad news? They took this out of our software. Yeah, it was there for, I don't know, 10 years, 15 years as part of the software, and then the newer versions, when they came up with OpenLab, it's no longer there. But let me give you the good news. Agilent has taken this out of the software, but made it into a little free program. So there is something called Agilent Lab Advisor, and that has, I don't know if I can say all the tools. It has most of the built-in diagnostic tools, most of the tests that I've showed you that are available in the system itself, and that's a free download. So lots of cool things out there. This is stuff that most of us have access to, but most of us have never been taught how to use it, and now you know how to use it. So that's some extra tips when it comes to HPLC troubleshooting and diagnostics. So if you want to see more tips and tricks like this, let me know in the comment section down below, and I'm happy to answer them. That's where this came from. Someone had a question, and it led to this answer. So let me know what I should answer next.